Unit 8, Lesson 5, Special Triangles. With Pythagorean theorem, we have 4 special triangles. The 45 triangle, the 36 triangle, and Isosceles triangle and Equilateral triangle. These 4 special triangles will help us to save time and to save calculation and to save us the time from using the Pythagorean theory. We're going to use it only one time to learn it, and after that we don't need to go through the Pythagorean theory to find missing let's say lengths of sides. And the other thing, that from previous, to use a Pythagorean theory we need to know 2 sides and find the third unknown side. But with special triangles, if the teacher gives us only one side, we can find 2 unknown sides. How it works, let's see step by step. So the 45 triangle, what the meaning of 45 triangle, or how we can know the 45 triangle? The 45 triangle means it's a right triangle and at the same time it's isosceles triangle. So as you can see, this is 90 degree, and in the meantime this side AC equal CB. And when you see something like that, that means this angle has to equal to this angle. And because you know that the sum of the 3 angle of any triangle is 180, 180 minus 90 is going to give me 90. If I divide 90 by 2, it will give me 45 and 45. And that's why we call this triangle 45 triangle. Why a special triangle? Let's see together the secret why we call this one special triangle. As you can see, if AC equals CB, let's say I'm gonna give each side the amount of 1. I want to make it the simplest one. So 1 equal to 1. What about the hypotenuse? We know from previous, from Pythagorean theory, that since hypotenuse square equal leg 1 square plus leg 2 square, I can apply this form here. I can say the hypotenuse is unknown. This is what I'm looking for. Leg 1 it's 1 square plus leg 2 it's 1 square. Why? Because they are isosceles and they are 45 triangles, so they are equal. So h square equal 1 square equal 1 plus 1 square equal 1. That means h square equal 2. That means if I want to find the hypotenuse only, equal the square root of 2, which means something with decimal. But I don't care about the value, I care about the square root of 2, so we can say square root of 2. So from here, why I did it in red, this is because it's standard relationship between the 3 sides of any 45 triangle. The relation is 1 square root of 2. Sometimes you can see some books, they are writing 1 dash 1 dash square root of 2. It's standard relation. You're gonna help me, okay, why this triangle is special? It's special because if I repeat the same triangle and now I erase this dimension, so I'm gonna use the eraser, I'm gonna remove this, and the teacher give me, let's say, an example, and it's saying that this side equal 5 centimeter and the hypotenuse it's unknown and this leg it's unknown. Can I find this dimension? For sure. If this one 5, right away CB equal 5 because they are equal. And AB, without using the Pythagorean theory, it's gonna equal to 5 square root of 2. I didn't do any calculation. Okay, again, if the teacher hide these numbers and give me another example, and he's saying that, let's say this is 6 centimeter and the hypotenuse it's unknown, the leg 2 it's unknown. Right away, when I see CB equals 6 centimeter, the other one it will be 6 centimeter. And right away the hypotenuse, without using the Pythagorean theory, it's going to be 6 square root of 2. The third one, which is a little bit confusing for some students, but the idea is very easy. If the teacher give me the hypotenuse and he is hiding the two legs. So let's see this one. If the teacher tell me that AB equal 8 centimeter, can I find AC and CB? For sure. If the relation is 1 to 1 to square root of 2, that means CB is going to be 8 divided by square root of 2. And because AC equals CB, that means right away this one equal 8 divided by square root of 2. Let's say I want to check if my work is right or not. Let's draw another quick equilateral triangle. Sorry, it's not equilateral triangle, I mean 45 triangle. Like this, let's say. And now I need to check. The relation was 1 to 1 to square root of 2. Don't forget, square root of 2, that means there is a hidden one here. 1 times square root of 2 equal square root of 2, which is logic. 1 square root of 2 equals square root of 2. That means the one that I have it here, it's repeated here. So if I have this one 8 over square root of 2, and this one 8 over square root of 2, and I know that the relation is, if this is 1, this is 1 square root of 2. That means I'm gonna take the 8 square root of 2 times square root of 2. If I simplify square root of 2, it's gonna give me 8, and this is what we have here. 8 divided by square root of 2, 8 divided by square root of 2. So this is how to show you that it's very easy. If the teacher give you one side, you can find two unknown sides, which is more powerful than the previous lesson that we have to go through, or we have to process the equation of Pythagorean theorem. Now, I use it one time to know the relation, but after that, with any problem, with any number, if the teacher give me one side, I can find two unknowns side. Let's go to another example of this special triangle. We call it, this special triangle is the 30-60 triangle. We need to understand what the meaning the 30-60 triangle before we start. The 30-60 triangle, it's coming from dividing an equilateral triangle in two equal parts. So you need to imagine that this was an equilateral triangle, and this equilateral triangle has 60 degree, 60 degree, and the third one 60 degree. We divide it in two. So the 60 divided by 2 equals 30. The second one, which is in this right side, is going to stay as it is. And we divide it with perpendicular, that means 90 degree. And the total for sure, 30 plus 60 equals 90. 90 and 90, it's 180. So everything is correct. Now, why we call this the 30-60 triangle a special triangle? I will show you again the same thing. We're going to find a relation in red between the sides. First of all, you know that the original of this 30-60 triangle, it's an equilateral triangle. That means what? That means this side, if let's say I have A, B, and this one is C, the BC here, it's the half of AB, because if I extend the BC like that, and I relate, let's say, A, D, let's say, this equal to DB, the total DB, because equilateral triangle. Now, because I divide it into two, that means AB will be the double of CB, or CB is the half of AB. So let's clean now. We understood why this relation. Let's clean now this triangle and keep only the 30-60 triangle without the equilateral. But we know it's coming from where, this relation. So I understand now that BC, it's half of AB, or AB is a double of BC. So in this case, if I call, or if I give CB 1 as dimension, that means AB right away is double, which means 2. So the relation is 1 to 2. Now I need to find AC, so I don't have a choice. I have to use the Pythagorean theory. So I'm gonna say again, since hypotenuse square equal leg 1 square plus leg 2 square, the hypotenuse is known, it's 2 square equal leg 1, let's say CB, it's 1 square, plus leg 2, I am looking for it, which is AC square. So now I need to use or to find the value first. 4 equal to 1 plus AC square. Now I need to use the inverse strategy to isolate AC. So I'm going to say 1 plus AC square. I need to isolate AC square, so I'm going to remove 1. That means I have to do the same thing from the other side. So that means 3 equal AC square. If I want to find AC now, I will say this is the square root of 3, and I leave this, and this is going to be my new relation between the three sides of any 30-30 triangle. Someone will tell me this relation will help me in what? If the teacher give me only one side, I can find two unknown sides. So I'm going to change the color with, let's say, blue, and let's try this calculation. If the teacher give me that this BC equal 8 centimeter and he's hiding the hypotenuse and the other side, can I find the dimension? For sure. If CB is 8 and I know that AB is a double, that means AB is going to be 16 centimeter. And if CB is 8 and I have here hidden 1 square root of 3, that means I can repeat the same thing here, and I can say this is 8 square root of 3. That means I found the value of the two other side without any calculation or any using of the Pythagorean theory. Again, let's repeat with another question from the teacher. If the teacher give me the hypotenuse and he's hiding the two other sides, how can I solve the problem? Again, if teacher tell me that AB equal 24 centimeter and I know this triangle is 30-60 triangle, right away I know that CB is a half of the hypotenuse, that means 12, because the relation is 1 to 2. So if this one 12 centimeter, what about AC? In this case it's going to be 12 square root of 3. And here again I found these two value without using the Pythagorean theory. So this is to show you the powerful of the 30-60 triangle as a special triangle. Why we call it special triangle. Now the third option that teacher can do is to give me the value of the third side and hide the two others. If the teacher gave me AC equal 18 centimeter, how can I find the hypotenuse and CB? I know that the relation is square root of 3, 1 and 2. That means CB equal 18 divided by square root of 3. And because AB is a double of this amount, so I can say 36, double of 18 over square root of 3. So from the 18 I found the two other value without calculating or without using the Pythagorean theory. And this is to show you the powerful of the special triangle 30-60 as the 45 triangle. Now let's see the other special triangle. We said isosceles triangle or equilateral triangle. Why here we call this special triangles? As you can see from the drawing, if you have an isosceles triangle AC equal AB, that means this angle equal to this angle. And the perpendicular divide the CB into equal pieces, which is very strong in my case. Why? In this case, I can find the area of this triangle by using the Pythagorean theory. So let's say the teacher gave me that this side 8 centimeter, this side 8 centimeter, and this side it's 8 centimeter. And the question is, find the area of this isosceles triangle. Before we know the Pythagorean theory, I couldn't find the area because I need the height, because the formula of the area of the triangle saying the area of any triangle equal half base time height. Teacher give me the base 10 centimeter, but the height it's unknown. So how can I solve this problem? In grade 7, because they don't know the Pythagorean theory, they cannot. But because we are in grade 8, we can find h. By using the Pythagorean theory, I can say since h square equal leg 1 square plus leg 2 square, and don't forget h here, it's not the height, it's the hypotenuse. So in this triangle, this half triangle, I can use Pythagorean theory. I can say what? The hypotenuse, it's 8, so 8 square equal leg 1. Leg 1 here became 5, the half of the side CB. Even if the teacher didn't give it to me, from the special triangles, we know that a perpendicular divide CB into equal base. So in this case, it's going to be 5 square plus leg 2, which means the height here, AG. So AG square. Now 64 equal 25 plus AG square. That means to isolate AG square, I'm going to use the inverse strategy. So AG square plus 25, and I'm going to remove the 25 to isolate AD. That means from the other side, 64 minus 25. In this case, I will get the zero pair, so AG square equals 64 minus 25. That means 9. 14 minus 5 equals 9, and after that it's going to be 5 minus 2, 39. Now I can use a calculator. I need the square root of 39 equal 6.24. So AG equal 6.24. Is this reasonable? Yes, because it's less than 8 centimeter the hypotenuse, so that means it's reasonable. And from here I can find the area by saying half time base, and this base, because of the base of the triangle, it's not 5, it's the 10, so times 10 times the height, which means 6.24. I can simplify 10 with 2, it's going to give me 5. That means the 624 times 5 equal 3122. And don't forget centimeter square. And from here we say this is a special triangle because I know that in any isosceles triangle or equilateral triangle, the perpendicular divide the opposite side into equal side, and from here, by using the Pythagorean theory, I can find the area. Someone will tell me this will help us in what? Let's say this example. Teacher give you hexagonal prism, and he give you one side 4 centimeter and the height or the length of the prism 10 centimeter. Let's say. So in this case, how I'm going to solve my problem? I need, let's say, to know the area of the base. Someone will tell me this can help me in what? The area of the base can help me to find the other area because both are congruent, and after that I can calculate the area of each face, and I can find at the end the surface area of the prism. So this could be the question of the teacher, find the surface area of the prism. And another thing, maybe the teacher will ask me to find the volume of the prism. How can I find the volume of the prism? We know that the volume of prism equal the base, the area of the base of the prism times the height or times the length. So if I have the area of the base, I can solve this problem. So in any case, I need the area of this hexagonal. This hexagonal base, I don't have any information except that one side equal 4 centimeters. The teacher didn't give me anything else. So how can I solve this problem? It's not easy, but we will analyze the problem with this way. I'm gonna try to redraw this hexagonal side, and this hexagonal, the teacher told me it's regular. That means all sides are equal. It is very important to know that it's regular for sure. Because it's all the sides are equal, that means all the angles are equal. And this is very important. So, can I calculate the angle? For sure. We know that the sum of the angles in any polygon equal 180 degree times n minus 2, which n is the number of the sides. I have the number of sides here 6, so that means 180 degree 6 minus 2. 6 minus 2 equal 4, that means 180 degree times 4. 180 and 180 is 360, 360 and 360 equals 720 degree. Now, if the sum of the angles is 720 degree, what about each angle? It's very easy to know. Because this is a regular polygon, I can take the 720 divided by 6, which means it's going to give me 120. That means each angle here it's 120, 120, and so on. Now, this will help me in what? I'm going to erase because I need some space. I'm going to erase this one. And let's say I need something now to find the area. How can I find the area? Before I find the area, with this calculation that we did it now, and we find that each angle equal 120 degree, this can help me in something very important. If this angle is 120, why I don't use diagonal? And you're gonna notice something very important, that this diagonal will divide the angles here into two equal angles, 60, 60. Again, 60, 60. And I don't have a choice. 60 plus 60 equal 120. I subtracted from 180, which is the total of the sum of the angle in any triangle, so it's gonna give me 60. That means with this discovery, I have an equilateral triangle. That means in regular hexagonal shape, I will have 6 equilateral triangles. Now someone will tell me, what is the importance of this one? The importance is from this lesson. We said if you have an isosceles triangle or any equilateral triangle, the height divide the side into equal space. So let's say this case, I'm going to take only one triangle. We said this is going to be equilateral triangle. That means the three sides equal 4, 4, 4. Now the teacher didn't give me anything about the height, but what I know here that the height divide the 4 into two equal pieces, 2 and 2. That means if I take this triangle outside, I will have a triangle with this shape. 4, 2, and unknown height. I can find the unknown height. Someone will tell me that means I can use the Pythagorean theory. But if you notice, this is the half of equilateral triangle. That means this is going to be 30 and this is 60. And if you remember our previous lesson about 30, 60, I have a good relation. 2, 1 to square root of 3. That means if I go here, if this is the double, this is 1 and this is 2, that means here the height without calculation is going to equal to 2 square root of 3. Or if you want to use Pythagorean theory, you can use, but at least you have this dimension. So if we need to calculate the area of one triangle in this regular hexagonal, we can find it. The area in this case is going to be half time base, the base is 4, time the height, I have the height now 2 square root of 3. So let's use the calculator, or we can simplify first. 2 times 2 equal 4 square root of 3. So let's find the area. What the meaning square root of 3? 3 square root of 3 equal this, times 4 equal 6.93. 6.93, let's say centimeter square. So from here I have the area of one triangle. If I want the area of the base, the area of the whole base, the hexagonal, regular hexagonal, it will be 6 times 6.93, because I have 6 equilateral triangle. So if I time this one by 6, I will get 4157. 4157 centimeter square. That means I got the area of the base of this prism. Now, if I need to calculate the surface area of the prism, it's very simple. I can double this dimension by 2. Why? Because I have 2 congruent bases, plus 6 times the area of the 6 different faces. So let's do it together. Area of 2 bases equal 41.57 times 2. So this one I will double it by 2. 8314, and centimeter square. I'm gonna put it in small rectangle because I'm gonna use it to add all faces together to get the total area or the surface area of the prism. Now I need one face only of this. The face, it's rectangle of length 10 and width 4. That means area of one face equal 10 times 4 equal 40 centimeter square. But how many faces I have? I have 6 faces. So area of 6 faces, it's gonna be 40 times 6, 240 centimeter square, and again I'm gonna square it. Why I square it? Because to find the surface area of the prism, it's gonna equal to 240 plus 8314, which will give me 323.14 centimeter square. And this was the first question of the teacher, how to find the surface area of the prism. Now the second question, if you look here, find the volume of the prism. The volume equal what? We know from previous that if the teacher asked me for the volume of any prism, not only this prism, equal the area of the base time the height, or we call it sometimes the length of the prism. So the area of the base, we have it from previous. The area of one base, it's 4157. So 4157 times the height of the prism or the length of the prism, it's 10. So times 10. That means I place the decimal point one step to the right side because it's multiplication and because by 10. So it's going to be 415.7 centimeter cube, because this is the volume. So that's why we call the isosceles equilateral triangle are special, because if you see from the beginning, the teacher didn't give me anything except the length of one side only. From here, with Pythagorean theory, and because I know the equilateral triangle is special triangle, I could find the height, I could find the area of one triangle, multiplied by 6 to find the area of the base. From here, I could find the volume and the surface area of the total prism. I hope you understood this lesson, and with this lesson, we finalized the chapter 8, which is the Pythagorean theory, and next one is going to be unit 6 for the circle. Thank you.